Gradient. Imagine you are standing on a hill and the ground has different heights at different places. The gradient tells you two things: which direction goes uphill the fastest and how steep that uphill direction is. In mathematics, the gradient is used with scalar fields, meaning a single value at every point, like temperature, height, or pressure. If the temperature is higher in one direction, the gradient points toward that direction. The steeper the change, the stronger the gradient. If the gradient is 0, it means the value is the same in all nearby directions, so there is no increase or decrease. In simple words, the gradient answers this question: where should I go to increase the value as fast as possible, and how fast will it increase? This idea is very useful in physics engineering and machine learning, especially when studying heat flow optimization and energy systems. Divergence. Now imagine a field of arrows like wind flowing through space or water moving in a river. The divergence tells us whether something is spreading out or coming together at a point. If more arrows are going outward from a point, the divergence is positive, meaning the point acts like a source. If arrows are pointing inward, the divergence is negative, meaning the point acts like a sink. If the arrows flow through without spreading or compressing, the divergence is 0. Divergence is used with vector fields where each point has both direction and magnitude. In simple terms, divergence answers this question: is stuff being created here, destroyed here, or just passing through? This concept is very important in fluid flow, electromagnetism, and curl. Finally, think about placing a tiny paddle wheel in a flowing fluid. The curl tells you whether that wheel would start spinning and how strongly it would rotate. Curl measures the rotation or twisting of a vector field around a point. If the flow causes rotation, the curl is non-zero. If the flow moves straight without swirling, the curl is 0. The direction of the curl tells the axis of rotation, and the size tells how fast the rotation is. Curl is commonly used to study vortices, magnetic fields, and rotational motion in fluids. In simple words, curl answers this question: does the field try to rotate things placed inside it, and in which direction? Together with gradient and divergence, curl helps us fully understand how fields behave in